Today we will shift from equations to inequalities. So let's get started. With equations, both sides of the equal sign are equal or have the same value. So here on our balance, our seesaw, one side has 4 plus 2, while the other side has 5 and 1. So both sides total 6. And our balance is balanced. There's an equal amount on each side. Well, what happens when we remove 2 from the right side? Now the left side is still 6, but the right is now 4. The two sides are no longer equal. The left side is bigger, and so our balance is lower on the left side. 4 plus 2 is greater than 1 plus 3. This is an inequality. Same is true if we add 1 to the right side. So our left side still has 6, but the right side now has 7. The right side is bigger, and the balance tips in that direction. 4 plus 2 is less than 5 plus 2. This is another inequality. Equations are used to show that two expressions are equal to each other. So we can have expressions like 4 plus 2 and 3 plus 3. These are equal to each other. They're both 6. We can also have algebraic expressions that are equal to each other. So we have 4x plus 2 is equal to 3x plus 3. And in the last unit, we solved equations like this to find the value of x that made this equation true. Inequalities are used to show that one expression is greater than another expression. And there are two types of inequalities. We have strict inequalities, and with strict inequalities, one side must be bigger than the other. So for this example, 4 plus 2 is bigger than 3. Or 4x plus 2 must be bigger than 3. They cannot be equal. Now with nonstrict inequalities, they may be equal. So now we're using the less than or equal to symbol, or the greater than or equal to symbol. So in this case, we have 4 plus 2 is greater than or equal to 3 plus 3. In this case, they are equal. Or the inequality 4x plus 2 greater than or equal to 3x plus 3. And in this unit, we'll practice solving these inequalities. So what do these things mean on a number line? In the last unit, we got a lot of answers that looked like this. The unknown variable x equal to some number, in this case 3. Well, our unknown x is equal to 3, and only 3. So it's that single point. It is the number 3 and nothing else. Now with x greater than 3, how we're going to show this is we're going to put an open circle at 3 because it's actually not equal to 3. This is only when x is greater than 3. So we'll use an open circle at 3, and then we're going to shade everything greater than 3. And this is how we'd graph this inequality. Does this include the number 3? No, 3 is not included here. But 3.1 is, because 3.1 is bigger than 3. So is 4. So is 1,000. Any number greater than 3 would be included. That's an infinite number of numbers. All of those whole numbers, fractions, decimals, and irrational numbers, including pi. So pi is going to fall right about here. So that's going to include our irrational number pi. So x greater than or equal to 3? Well, now we're going to include the number 3. So number 3 is in this set of numbers. And so are all the numbers bigger than 3. So once again, we have 3.1. We still have pi. We have 15. And we have 10 million. Every number bigger than 3 or equal to 3. For x less than 3, once again, we'll use that open circle to indicate that 3 is not in this set. But everything less than 3 is. So I'm going to go ahead and shade this number line to the left of 3, smaller than 3. So now we have numbers like 2.9, or 0, negative 15. And negative pi would be okay. Negative pi would be right about here. And finally, x less than or equal to 3. We'll do a closed circle at 3 because 3 is included. And then it's less than, so we're going to shade everything to the left or smaller than 3. So again, we have numbers like 3 and 2.9 and 0 and negative 10 million. All those numbers that are smaller than 3. So a key difference, when we have x equal to 3, that's one number, the number 3. But for these other 4 cases, there are an infinite number of numbers that are in these 4 sets. There's an infinite number of integers bigger than 3. There's an infinite number of rational numbers greater than 3. There's an infinite number of irrational numbers greater than 3. There's only one number equal to 3. In the previous slide, we practiced graphing inequalities. Now let's practice writing an inequality from the graph. So we're going to start with an unknown. And we'll have x as our unknown for this first one. And what we're going to end up with is an inequality that says x, and then some relationship, so is less than, is greater than, and then a number. And so the number here is where the circle is. The circle is at 5. So we're going to put 5 here. And the number line is shaded to the left of that number. So that's less than. So we'll put our less than sign. And then we have an open circle. So that means 5 is not included. So the inequality is x less than 5. For the second one, again, we'll use x as our unknown. And we have the circle at 0. So 0 is our number. Kind of that boundary where the inequality ends. And once again, it's smaller. So it's going to be less than. And since we have a closed or filled in circle, equality is possible, so this will be less than or equal to 0. For this third one, again, our unknown will be x. And we're starting at 1, so we'll put 1 here. And now our unknown, the shaded side, is greater than or bigger than 1. So we'll use the greater than sign. We have an open circle. 1 is not included. We do not have equality. And then finally, again, unknown of x. The number is negative 5, where the circle or dot is. It's less than it. The left side is shaded, so that's going to be less than. We have a closed circle, so that indicates equality is possible. So we have x less than or equal to negative 5. If it's an open circle, that means the number is not included. So a strict inequality. So we'll use the less than or greater than sign. And if it's a closed circle, the number is included. So it's a non-strict inequality, and we'd use the less than or equal to or greater than or equal to. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 4 problems. So if we have a less than -4, first thing we're going to do is find -4 on our number line. And then we have an open circle here because we have a strict inequality. So -4 is not included. A is less than -4. So we're going to shade to the left, to the smaller numbers. For the second one, we have b greater than or equal to 2. So we find 2 on our number line. We're going to fill in that circle because 2 is included. And then b is greater, so we're going to shade numbers greater than 2. Writing an inequality from each graph. Again, I used x for the unknown, but you could have picked any variable for this. Here we start at -2, so we have -2. We're shaded to the smaller side, less than -2. So we use the less than sign, and we have a closed circle. So -2 is included, so it's less than or equal to. For this last one, we're at -5. We're shading numbers greater than -5. So we're going to use the greater than sign. We have an open circle, so it's a strict inequality. We do not have equality in this case. We do not have it being equal to -5. So x greater than -5. Continue practicing graphing inequalities, and I'll see you in the next video.